Alright, so our next unit is on energy, and we're going to be looking at different forms of energy over the course of this unit, and also how energy can actually move from one object to another, mostly in the form of heat. So when we first talk about energy, we actually have to kind of define what it is, and defining energy is not all that easy to do. Energy is something that you can't really hold in your hand or that I can buy a bottle of, but it's a very important part of our universe. If you look at things in the universe, they are made from a combination of energy and matter. So if you look at the desk or the table that you're sitting at, or the chair that you're sitting in, or the computer that you're watching this on, it is made up of a combination of both matter, which we talked about before, and this idea of energy that we're trying to define. Now, one way to think of this is that everything that we look at in the universe is made up of matter, which is the actual substance that we see, and energy is kind of the mover, or the part that actually holds it together or allows it to move from one place to another. So because energy is something that we really can't see, we can't hold in our hand, how do we know that energy actually exists? Well, that's because when we most often notice it is when it is changing, and energy is involved in every change that we have on Earth. When you blink your eyes, as you're writing on your papers right now, those are all energy changes, or those are all changes that involve energy. So one way that we can actually define energy is the ability to cause change. So if we don't have energy, we don't have that ability. And so since everything in the universe is made up of the combination of matter and energy, everything within the universe has the potential to change. Now, energy comes in many different forms, and we're going to look at some of them, and we're also going to talk about how it is able to change forms from one form to another, because that is actually really, really important here on Earth in order for us to have things change for us. In addition, energy can be transferred from one place to another. So let's take a look at some of the different forms of energy that we have. We have chemical energy, which is found in the chemical bonds. For instance, in the foods that we eat, that's actually what we are after as humans. We want that energy that are stored in those chemical bonds. Gasoline, the cars work the exact same way. Thermal energy, this is the type of energy that we get from the sun. Also the heat from friction. If you take your palms of your hands and put them next to each other and rub them back and forth, that thermal energy, that heat that you feel, is thermal energy, and it's generated due to the friction. Electrical energy we are very familiar with. It powers our phones, it powers pretty much everything that we use. The lights that are in the room, different appliances that we have in our house, our microwaves, our refrigerators. Mechanical energy. Mechanical energy is related to the energy of movement, but it involves things like trains moving things from place to place, as well as people who are running are using mechanical energy. Electromagnetic energy is things like X-rays, as well as light. And I know you've learned about the electromagnetic spectrum, which involves all those different components: microwaves, infrared, ultraviolet. So we could have listed a lot here that you would have been familiar with. And the last one is one we actually talked about earlier this year, which is nuclear energy. This is the energy that actually holds the atom nucleus together. So let's take a quick look here at this video clip about how energy is able to change forms.
One of the most remarkable things about energy is that it is constantly being changed and recycled from one form to another. These sheep eat grass and convert the chemical energy stored in the leaves into a form of energy that can be used in their bodies. That is an example of an energy exchange. Much of the success of our industrialized world has come because physicists and engineers have learned to convert energy into more usable and convenient forms of energy. Electricity has become our most important source of energy. It can be generated in different ways, but the most common method is when magnets are rotated in an electrical field. Kinetic energy is needed to rotate those magnets, and there are various sources of that energy. Steam power from the burning of coal, natural gas, or nuclear fission is one method. Wind and solar power are others. Water power is one of the most environmentally friendly sources of energy. Water sits above this dam as potential energy. It is drawn down a tunnel by the force of gravity. There, the kinetic energy of the moving water spins blades in a turbine, which in turn spins magnets and produces electricity that is transmitted over power lines. In your home, the energy in the electricity can be converted to various uses, such as light in electric light bulbs, heat in stoves, and it can run various machines, like coffee makers and CD players. At every point in this process, energy is being exchanged from one form to another. Another example of the conversion of energy is the automobile. Gasoline sits in the tank of a car as potential energy. When the engine is started, the gas is sucked into the cylinder, mixed with air, and exploded with a spark from the spark plug. When the car is put in gear, the energy of the explosion becomes mechanical energy when it pushes down the piston. That energy is transmitted through a series of gears in the drive shaft to the wheels. The wheels push on the road and move the car. All of this is a series of energy exchanges. Car engines, like all machinery, have a serious problem with heat, a byproduct of the mechanical or chemical processes. About 70% of the energy produced by the exploding gasoline is converted to heat. Cooling systems are essential, or the metal in the engine would literally melt into junk in seconds.
Okay, so there you can see how our energy actually does convert from one form to another, and we will take a look at that in a little bit more detail as we move a little further into the unit. Now, in terms of actually measuring energy, because remember that's one of the things that we do, energy actually occurs in what we in chunks or little packets, these little quantities that we actually call quanta. If you've heard the term quantum physics, that's where this actually comes from. Quantum physics actually is the study of energy in relationship to physics. So that's actually what we're doing right now. Another way to define energy, it is the ability to do work. In other words, take an object and be able to use a force to move that object a certain distance. The units for energy are the joule, and we will see that we use that unit no matter what type of energy that we look at. So what I want to do to kind of finish off this first segment of the unit is to take a look at our first form of energy, and it's one that you're familiar with from your previous science classes, and this is kinetic energy. Kinetic energy is the energy of motion, and this motion can be actually moving things from one place to another, or it can actually be the kind of wiggling or wobbling of the particles, excuse me, of the particles of a substance in place, like with a solid. Kinetic energy is depending on two factors of the object, the mass and the speed. So we can actually calculate kinetic energy using a formula, Ke equals 1/2 mv squared, where m is the mass and v is velocity, as we learned last unit, or the speed. Now, in a little bit, in a couple minutes here, we will actually go through some practice problems using that formula. But let's talk a little bit more about what this formula tells us and some of the different types of kinetic energy that we can have. If I look at that formula, if I increase the mass of an object, that means I'm also going to increase the kinetic energy. By the same token, if I increase the speed, I'm also going to increase the kinetic energy. However, if I look at the two, the one that has the greater effect on kinetic energy is the speed, and that's because I'm squaring it. Remember that when I have and do kinetic energy calculations, my unit is always the joule, which is represented by a capital letter J, and that is the SI unit of energy. So kinetic energy is the energy of motion, and we have some different forms. The first form of kinetic energy is linear kinetic energy, and this is where we get motion in straight lines, like with a car or a jet. We also can have rotational kinetic energy with objects that spin or rotate, and a great example of this is the Earth. We spin on our axis. In other words, every 24 hours we kind of come back to the exact same location that we were as we spin, but we also are rotating at the same time around the sun. Vibrational energy is motion due to friction or heat, and this would include the energy of different particles of matter that they have based on their phase or state, whether it's a solid, a liquid, or a gas. But by and large, the biggest type of kinetic energy that we have is wave motion, and this is the type of energy that moves in waves. And you learned about some of these in your previous science courses with like electromagnetic radiation. All of those come in waves, visible light, sound, but you also, when you think of waves, you may also think of like the beach and the ocean, and those are what we call matter waves. So we have electromagnetic radiation that we talked about, the light, the sound, the infrared, the UV, matter waves like in the ocean. Electricity also moves in waves because the electrons actually move in a wave-like pattern through the wires. And thermal energy, like with a fire, if you think about the flames in a fire, you can, if you imagine those actually move in a wave-like fashion, and those atoms are moving in a wave. All right, so one of the things that you will have to be able to demonstrate is that you can actually solve some kinetic energy problems. So let's take a look at some practice problems here. All right, the first one. Sorry, my pen is not working like it's supposed to here. Come on. That was working. A 0.10 kilogram bird is flying at a constant speed of 8 meters per second. What is, nope, it's not working. What is the bird's kinetic energy? So let me see if I can, there we go. All right, so let me get a color that we can actually see here. So if you remember, our formula is KE equals 1/2 mv squared. And if I look at my problem here, the mass is right here, and the mass should be in the unit of kilograms for this. And my speed is listed here, so all I have to do is actually plug that into my formula. So 1/2, my mass is 0.10, and my v is 8.0, and please do not forget that you have to square that. Remember, when you punch it into your calculator, what you will do is the 1/2 becomes a 0.5 on your calculator. We don't want to write things in fractions in terms of our answer. So we would have 0.5 times 0.10 times 8 times 8. And when I do that on my calculator display, I get 3.2. Now, before I record my unit, let's double check our sig figs, because if you look at mass and the speed, those are things that we actually measured, so we do have to take into account the sig figs. With the 0.10, I have 2 sig figs, and with the 8.0, I have 2 sig figs. So if I look at 3.2, I also have 2 sig figs, so the only thing left to do is to write my unit, which is joules. All right, let's take a look at the next practice problem. This time we have a 70 kilogram man who is walking at a speed of 2 meters per second, and we are trying to find his kinetic energy. So again, I have my mass here at 70 kilograms, my speed at 2 meters per second, so I just simply use my formula and plug in to solve for the kinetic energy. So 1/2, my mass is 70, and my speed is 2.0, and I'm going to square that. So again, on my calculator with this 2.0 being squared, I just simply multiply twice, 2 times 2. When I plug this into my calculator, I get the answer of 140. Now, if I look at my measurements, the 2, again, has 2 sig figs, whereas the 70 has 3. My 140 has 2, so that works, and I just need my joules for my unit. All right, let's take a look at the next one. All right, a 1,400 kilogram car is moving at a speed of 25 meters per second. What is its kinetic energy? So, using that formula, we are going to plug in. And remember, on your test, you're going to have to show your work, so it's a good thing to get into the habit of doing that now. All right, and when I get that answer on my calculator, I get 437,500. Now, 1,400 has 2 sig figs, and the 25 has 2 sig figs. But as this is written, this has 4 sig figs, so I do need to change the sig figs on my final answer. I know I'm going to have a number here at the 4 and here at the 3. So I know this is going to change to a 0, and I know the 7 is also going to change to a 0, but before that happens, it's going to round that 3 up to a 4. So my final answer would be 440,000 joules. Now, the last practice problem is a little bit different than the other 3 in that we can also solve for something different besides kinetic energy. In this case, we have a cheetah that is running, and it is a 50 kilogram cheetah, but we're given the kinetic energy, and we're being asked how fast. So this one I am solving for V. So when I set up my problem, I'm actually going to put 18,000 on this side, and then my 1/2 times my mass times V squared. So I have 18,000 equals 25 V squared. Divide both sides by 25, and I get 720 equals V squared. Now that looks really great, but that's not what I'm solving for. I need to now take the square root of both sides in order to solve for V. So I know that V is going to be the square root of 720, which on my calculator comes up to 26.83281573. Now, obviously, that's way too many numbers, and if I look back at my numbers, my 50 is 3 sig figs, but my 18,000 is only 2. So this can only have 2 sig figs, so when I round it correctly, it's going to be 27. Now, you don't just get in the habit of slapping down the J for joules. I am solving for speed here. This is in meters per second. In the next lesson, what we're going to do is we're actually going to look at potential energy and learn how to calculate its different problems.